All right, welcome back to day 35 of LeetCode grind. Solve or go home. 30 minutes. Solve or go home. Okay, let's see what we got. Delete operation for two strings. Okay, given two strings, word one and word two, return the minimum number of steps required to make word one and word two the same. In one step, you can delete exactly one character from either string. Okay, yeah, very simple question. The algorithm is probably what's super difficult. Okay, so yeah, I think what you want is, yeah, like you were saying, right? So you want to find their common subsequence, right? And then given that, you know how many operations you need.
Uh, right.
Is that even
So,
is that even DP? That doesn't seem like DP at all. You just need to grab this common subsequence, right?
right, but the method for getting common subsequence is DP, or it can be DP.
Oh wait, I thought it was just straight up. You look at the longest. I wait. It is not technically longest common subsequence. It's you want to find all the common subsequences, right?
No, you want the longest one because you have to delete everything else. So
No,
let's
no,
say
no,
there's
no,
no
no,
other
no, no.
operator.
So yeah, let's say you had two common subsequences in a word, right? Right. Okay. Like for example, you had
What does
like
that mean?
yeah. So like let's say eat the steak, and then you got eat the rice. Okay. No, that's too easy. Let's say eat um eat good steak. How about that? Okay. So technically, if you're saying longest common subsequence, that's just the steak word, right? Because that's the longest one.
Oh, no. Eat and good. Oh, sorry. The good will be popped out and the will be popped out, but everything else is good.
Yeah. So okay. So that's why I was misunderstanding what you're talking about. Common subsequence. That's not a subsequence because then the words are
It is a
separated by.
subsequence.
Yeah. Only if you can pop it out words, then it's a common subsequence. But
Right.
the
What
technical
would be?
definition of subsequence is it has to be continuous. If you're popping shit out, then
Oh,
that's not continuous.
that's a substring. That's different.
Well, what the hell is a subsequence then?
Like any component that's in a row that is, or sorry, in order, that doesn't have to be contiguous.
Okay, so it doesn't have to be continuous. Okay, sure. I didn't know the definition of subsequence. Okay, that's fine. All right, so given that, let's say, okay, so if we're looking for the longest common, technically, couldn't you say, let's say, okay, um, you just loop through both words, right?
Mm.
Build, build, um, what is it called? Nope, not that. Yeah, that doesn't work. Okay. Nah, I don't know what I'm talking about. Okay.
Wait. So let's say you had an algorithm that allows you to return eat steak as the longest common subsequence of both of these words.
Mm-hmm.
And what would your answer be?
Okay, so it says each. So you have two words of each. Okay. And then you need to return the minimum number of steps to make word one and word two true. So I guess minimum is four because you have to delete good. Each step is what? In one step, you can delete one character from either. Okay, so you need 7 steps.
Right.
Yeah, so output would be 7.
Right.
Okay. But that's the easy part. The hard part is getting the subsequence.
Right.
Mm-hmm.
Okay. Maybe we use a smaller example, but we can walk through I guess the algorithm for matching.
Sure.
Right.
So if you want to eat easy one, just do like eat and eats or something.
Okay. So let's say you compare one word on one axis and one word on a separate axis, right? So you have length of word 1 by length of word 2 array.
Length of word 1 and length of word 2, you said?
So make a grid where each is on the across and then each is down.
Oh, you mean like
As it is in drawing.
like that?
Not quite. So, both words, like, it's not guaranteed that they will intersect at E, right?
Yeah. So what
you,
are you saying?
kind of like this, but above line 4. No, don't delete that.
Above what?
But just undo what you did.
Oh, you want those words back? Okay.
Yeah.
They're back.
Right? And then on line 6, delete AT.
Okay.
And then on line 5, do a comment of space EAT. Right?
Okay. So okay. You're doing
Okay.
like a
So
comma.
now, how would you compare and say like, oh, what's the longest common subsequence? You know it's gonna be eat, right?
Yeah.
Okay, so you compare E with E, right?
Yeah.
And you're like, okay, how long is the common subsequence here, right?
Yeah. Wait. I
So
think I thought of something that might work. So how's this? How's this? Wait, actually no. It won't fully work. Maybe I'm not sure. So I'm thinking like
okay,
maybe.
so
Go ahead.
okay, do you want me to teach you the method to do this, or do you want to try to figure it out yourself?
Um, I don't know. Maybe I can say my method. If it doesn't work, then we just go with
Okay.
yours because I have no idea. So okay. So how about like you loop through one word, right?
Mhm.
And then while you wait, actually does that work? Because if the other word starts at a different index, then yeah, never mind. I don't think that works. All right, whatever. All right, let's just stick with this.
Okay. At the beginning, you have nothing matching. Right?
Uh-huh.
When you compare the first index with the first index of the next word, right?
Yeah.
So word 1 0 and word 2 0.
Yes.
E, right?
Mm-hmm.
So you know the minimum. Like if you choose this letter, then you just have to do calculations on the rest of it, right?
What do you mean by calculations and the rest of it?
At the beginning, when you choose, you don't choose any index. The longest match is 0.
Longest match is 0. Yeah, yeah.
Okay, but when you look at index 1 of index 0 of both words, they match.
Yes.
What can you say about the longest match?
Currently it's E.
Or 1, right?
Oh, you talking about just length? Yeah, 1, sure.
Or let's do it. So if E and E is the same, then you put a 1 there.
Okay.
Right?
Oh, you mean in the grid?
Okay. And then now you compare E against A, right? In that row.
Yeah, that's
Are
not
they the same?
not match. So 0?
Okay. But you know E compared to EA. Don't it's not 0.
Oh.
So that means E compared to EA, you have 1 match so far.
Mm-hmm.
And what would happen is if you were to like return it, you would probably just delete the A, and then the longest subsequence is still E, right?
Okay.
But it's gonna be 1 still, right?
Oh, because you maintain your current count, but you don't increment it. Because you're allowed to delete that.
Right.
Okay, sure.
Then E against ET, E against T, right? Same thing.
Yeah.
It's 1, right?
Mm-hmm. And then this one's also 1.
Yes.
Okay, question though. What if it was EATE? Would the second S be a 2? No, would second E be a 2? That doesn't make sense though. Does that make sense? Bro?
Maybe 2. I think so.
No, because if you think about it, right, E's only gonna match it with E, but then if you have one E on one word and you have 2 E's on another word, that other E is useless. Why? Right? So what's the point of incrementing this? Shouldn't it just be 1 across the board?
Well, the point of incrementing is that you. Wait, it's always differ by at most 1.
What do you mean by differ?
Compared to the previous longest subsequence, and you're going to either be the same or plus 1, right?
Okay. Yeah, but okay. So when does a plus 1 happen?
What happens when your thing is the same?
So if you have 2 E's on one word and 1 E on the other word.
Oh, sorry. No. Okay, my bad. This is all wrong actually. But let's go back. Go back.
Go back to what?
Okay, we need a grid of zeros first. With size 1.
Size 1?
Okay, so you shouldn't compare E to E. No, you should compare E to E, but you are not adding it to. It's not 1 here. It's actually. Okay, so you need you need one. You need like a dummy variable in front of the E, like an underscore.
Okay, what does that do?
Put a space there, and then line 6 should be underscore also. And so the first row is all zeros.
What is considered the first row?
What? Press enter. Like you need another line right now.
Under what?
In line 6 to split the underscore and the E. Underscore is a letter, let's just say. It matches nothing.
Oh, so put E back down?
Okay. Then on line 5, put a space.
A space where?
Front.
There is you mean a space before underscore?
Yeah.
Okay.
This is your grid. This is what you're comparing. Okay, so now the first row and column should all be zeros.
First row and column should all be zeros.
For the column?
What column?
First column.
Oh, you mean the underscore column?
Okay. Underscore can't match anything.
Wait, then that pushes the E over. No, the letters.
No. Your grid. Oh, okay. Okay. So the outermost thing. This is just to show you the words, the letters. And the inner grid is the longest sequence.
Like this?
You're building DP right now.
Yeah, but I don't know why we're doing it like this. I don't get it.
So when you find a match, which is E matches to E, right?
Uh-huh.
And that means you take the previous longest up to that point, which is index I minus 1, j minus 1.
I minus 1, j minus 1. Okay.
Which in this case would be 0, 0, right? Because you're filling in for 1, 1 now.
1, 1. Is it 1, 1? Index 0, 0 is origin. 1, okay, this is 1, 1. Yeah, okay. So I minus 1.
Right, so because E equals E, right?
Yeah.
Know that the previous longest was basically 1 to the left and 1 up. Okay.
1 to the left and 1 up. So you're saying add 0, 0.
0, 0. And so you take that guy and you add 1 to it because you found a match.
Okay.
That's why this 1, 1 index is 1.
Okay.
And now if you compare E, let's say E1, right?
E,
Not a match.
you say E with A, you say?
Yeah, E with A.
Mm-hmm. So it's not a match, so you don't add 1.
Not a match. So you don't look at the diagonal element, but you basically look either left or up. It's one of those guys.
Oh, what do you mean by it's one of those guys?
It's going to be the longest up to that point, right?
Yeah.
Basically, you're comparing E to EA. The A is going to be like, oh, this A is useless. So if I drop this A, I still have the 1 from the E.
So you get the max between left and top? Is that what you said?
That resolves your EATE problem because the E at the second position will still be adding a 1 from the 0. Then it's the max between no, it's always the one up and to the left, which is the shorter substring, the maximum so far, and then you're adding 1 to that. And if it's not the same, then you pick whatever you have best so far.
Yeah, so the max between left and up. Oh, okay, okay. So the algorithm is if it's match, you take the left plus the up plus 1, and then if it
no, if it's matched, you take up and left plus 1.
Yeah, that's what I'm saying. The sum of up and left plus 1.
No, not sum. Diagonal elements.
Okay, so you take the specific element plus 1.
Correct. Because
But then
the diagonal element was the previous longest string. It did not include this index.
okay. And then if it's not a match, you just take the max between left and up.
Which is the previous longest index, either deleting the last element or not deleting the last element. Or sorry, deleting the last element from the first word or deleting the last element from the second.
Okay. Okay, so if it is a match, you're taking the diagonal plus 1. But then if it's not a match,
you understand
why? What we say?
You understand why?
Kinda, because then the diagonal is basically the solution of the longest substring.
All right. So the 0, 0, 0, 0 stuff means that the match so far is all empty string.
Sure.
Okay, so then when you're like, oh, E plus E, then you're like, okay, I'll take empty string, I'll add an E to it, and then that's my current longest string.
Yes. That's fine. Okay.
But if you don't have a match, then the longest string is either going to be whatever you had to the left of you or whatever you had to the up of you.
Mm-hmm.
Because your current letters do not match, so that cannot add anything. So that means your longest is whatever
You currently had. Yeah, that makes sense. Okay, so then, yeah, if I were to fill this out, then there'd be 1, 1, 1 here, this one would be 1 here, 2, and then this one is 3, I guess. And then you just take, and then whatever number is at the last index of len word 1.
The longest common subsequence.
Yeah, so then that would be the longest common subsequence.
Okay, so that would be the each state or whatever of the previous.
Okay, and then given that, you just take the length of word 1 plus length of word 2 minus that, and that's your answer.
Minus. Wait, is that true?
Wait.
No.
Wait. So length of word 1 is 4. Length of word 2. No. Okay, no. It's length of word 1 plus length of word 2 minus 2 times that number.
Exactly.
Okay. So I just have to build this 2D array, and then I just do that.
Okay.
So I want to return.
The hardest part is understanding why this array works.
I mean, I kind of understand how it works, but then I would never think of how to build it.
So it's bottom up DP, right? Like you're building what is the same, and if condition matches, then you extend by 1. So the condition of matching is when you have the same letter. So if you pick that letter, then you're taking the value from shorter string. If you don't take that letter, then you're taking the best so far.
Sure. Okay. Alright, so basically you instantiate a 2D array with the first row and the first column being zeros. Well, actually, no. You just build the whole thing zeros, and then you just loop through and build the rest of it, right?
Yeah, that's fine.
Okay, so rows equals len word 1. And then you want to instantiate r equals 0, 4.
Range.
0 for I in range rows. And then how do you do the column part?
Well, put this into another bracket.
Oh, bracket outside of it?
No, inside of this.
Oh, inside.
So rows should be. Yeah, so do for columns and then for rows.
Wait, so 0 for I in range columns? And then when do you do the range, the rows part?
Do on the outside, say for A in range.
Okay.
No. This should be on the right side.
The right side of what?
Square bracket closing.
Like that? Like a second square bracket?
No. The right square bracket is correct, but you want a nested one, so the left square bracket of the right side is wrong. Should be at the very beginning.
The left square bracket.
No. Oh. Yeah, okay. You're doing a bracket of a bracket.
Sure, I just don't. I don't understand the syntax. That's it.
Okay. You have 2 square brackets. The inner square bracket is for calls. The outer square bracket is for rows. That's right. Well, no. Rows is in the wrong place.
Oh, it's columns before rows?
Because you're building out the column, and each row has that many columns.
Okay. Does that work?
No. Because you have a second 0 that's just there for no reason.
The outside or the inside?
The outside.
Does that work?
Okay. This should work. It's also missing the empty string underscore thing.
Do we need that? If we already built it with zeros, do we need that?
You build it with zeros.
No, because this. Oh, I
Okay,
see what
what's
you
the
mean. I see what you. I
dimension
see what
of
you mean. Because this is exactly the length of eat and eats, so I need a +1 to it. Right.
Yes.
Okay, so it's a 4x4. Is that even? Oh, that's because their input was C and eats. Should be a 5x4. Yes. Okay, that looks good. Alright, that's fine. Okay. And then I just want to start at 1, 1. So I do, okay, I do for row in rows, in range, rows of 1 to rows, and then for call in range 1 to calls. Then I do if okay, so I need to also set up the word.
Hang on. Looping through rows and calls, but you'll miss the last index.
Wait, why will I miss it?
You're starting with 1. This will go EA instead of eat, and then it will go EAT instead of eats.
Oh, so I need the +1.
Okay.
Okay, but I still need to map the word. So okay.
Yeah, that's an R.
What'd you say?
What do you mean map the word?
Because then I need to check to see if the letters match. So right now, if in this array, so, okay, so I guess row is the index of the word, but then the word.
Then let's just use range. Let's just use range, but don't use 1 for that. You want all the word ranges.
Yeah, but then that means it will start.
You want to start with 0.
Huh?
Start with 0. I want to start with 0 for the words.
Yeah, I know, but then the matrix you're gonna start at 0, 0. Then that's wrong, isn't it?
So fix it. Okay. Well, either you're going to have the wrong index for the matrix, or you're gonna have the wrong index for the word, and you can have both.
I think it's easier to have the wrong index for the word because you just -1 in that.
Well, then you can also just +1 for the matrix. I mean, it's the same thing.
Okay, fine. Alright, so then you would do okay, if word row goes word, what's word 1 row, I believe, word 2 column, then you do R row +1 column +1 equals R row R column +1. And then if it's not equal, R row +1 column +1 equals the max of R row. So if I'm plusing 1, but I want a minus 1, so it's just row. So I want to check. Okay, so I want to check the maximum between this one and this one. So if I were to do that, that is 1 1, and this index is this. This one is 0. So 1 1 and 0 1. Is it 0 1? No, that's 0 2. Wait. Is that 0 2? Yes, it is 0 2. So if it matches, okay, so if this index 1 1, if it matches, I want 0 0. If it doesn't match, I want 0 1. And wait, is that 0 1? That's not 0 1. That's 1 0. This one is, which one is this one? This one is 0. Wait, is it 0? No, wait, this is, wait a minute, no, this one is 0 1. Shit. 0 1, and this one is 1 0. Okay, this one is 0 1. And this one's 1. Wait, no. This is not. Yeah, wait, no, this is also 0. What? No. Oh, row 1.
Yeah.
Row 1, column 0. Okay, it's 1 0. Okay. So, and then at my current place in the array, I am currently at row plus 1, col plus 1, which is equal to 1 1. So that means I want to have the max of row and col plus 1 and r of row plus 1 and col. Okay, that looks fine.
Sure. The 2 lines above is some issue.
Wait, really? What's up with it? Oh, whoa, oh. What the hell? Why do I have extra R in there? Okay, that should be fine. Okay, that looks like it was the right array. 0 0 0 1 1 1 0 1 2 2 0 1 2 3 0 1 2 2. That doesn't look. Wait, no, it's 0 1 2 3. My bad. Yeah, that looks right. Okay, so I just want R of len or -1, -1. Okay, let's try to eat this steak. Good steak. Should be 7. Alright, looks good. Q.
Right. Well, I don't know. So if this doesn't make sense, you should probably like look up longest common subsequence.
Yeah, I will. I will probably reveal this video
because
later on too.
Well, right. The logical. Maybe I should have had you walk through logic. But basically, there's 2 main scenarios, right? At any given point, you're either extending the previous longest by 1, in which case your guys match, or you're taking your previous longest from either side.
Yes. Yeah. Well, that's the basic logic.
Into building this 2D array and like saying like, oh, if it's the same, then take the thing from the diagonal before it. If it's not the same, then take the maximum of what's there.
Mm-hmm.
You have to understand why that is, why this was chosen. Yes.
Yeah, I would never think of using a 2D array for this. So yeah.
Okay. Yeah, it's tricky. I mean, I don't really know how to explain this very well. So
That's fine. I'll probably look up something, read up on it. But yeah, I also have this. I can also reveal this video at any time, so that's good for me too. All right, thanks.
okay.